All right, guys, we are on a practice day so that we can make sure we've got all of this content down pat and that you're understanding, evaluating, and the properties of logs as we go. So as always, we're going to start with the log song. And again, today we're going to be working on properties of logs, expanding, condensing, and I believe there's a little bit of evaluating in here as well, and converting back and forth between log and exponential form. So here is our log song. I don't know where the video is or the noise. Sorry, I could sing it, but you don't want me to sing it. It's log, log, log. All right, so here's the end of that. Sorry, I cut it short. Don't know why the sound didn't play on that guy, but that's okay. So we are reviewing our properties for condensing and expanding. Hopefully you remember log base b of m multiplied by n, that is the product property, and you separate it with addition. And log base b of m divided by n, that is the quotient property. That is division. So you can separate it with subtraction. And last but not least, the power property, log base b of m to the power of p can be separated with multiplying by a coefficient. And we're going to review every single one of those as we go through this practice. Here we go. So our first example is log base 5 of 3 multiplied by 2 squared to the power of 6. So we've got a couple of different properties in here. Do not multiply the two things that are in parentheses. I mean, we could eventually, but we want to use those properties that we have and practice them. So we're first going to use our power property of exponents and multiply 3 to the 6th power, and then 2 squared to the 6th would become 2 to the 12th power. So our argument is now 3 to the 6th, 2 to the 12th. So we'll write log base 5 of 3 to the 6th multiplied by 2 to the 12th power. Because they are being multiplied together, then I can separate those with addition. So log with the same bases for each term, log base 5 of 3 to the 6th plus log base 5 of 2 to the 12th power. And then our last thing to fully expand is to take those powers and make them become coefficients in front of each of the individual terms. So it will become 6 multiplied by log base 5 of 3 plus 12 multiplied by log base 5 of 2. That is as expanded as that first example can get, no farther. Example 2 has log base 7 of a multiplied by b multiplied by c to the 6th. The only term that has the power property is c to the 6th power. That's the only one we'll use that property with. We can go ahead and separate each of these as 3 separate logs with addition in between them because we have the product property. Log base 7 of a plus log base 7 of b plus log base 7 of c to the 6th power. This answer is great, but not complete. Again, we need to take that power property for that last term and write it with it as a coefficient. So log base 7 of a plus log base 7 of b plus 6 multiplied by log base 7 of c. Okay, our next example 3 is log base 3 of x to the 5th multiplied by y, all raised to the 6th power. Again, go ahead and use the power property of exponents to simplify the argument. Log base 3 of x to the 30th, multiply those exponents, and y to the 6th power. Now that I have those two terms in the x to the 30th and y to the 6th multiplied, I can separate them with addition using the product property. So log base 3 of x to the 30th plus log base 3 of y to the 6th. And now we're going to use the product property of logs and take those exponents and make them coefficients. So 30 multiplied by log base 3 of x plus 6 multiplied by log base 3 of y. All done. Number 4, log base 3 of 12 cubed divided by 5 cubed. Couple of different choices for this one. You could rewrite the 12 cubed and 5 cubed as 12 over 5, the entire thing cubed, but I'm going to leave them as they are because our goal is to expand it as fully as possible. So those powers are going to become coefficients anyways. So let's just keep it as it is and separate our quotient property, the division, and change it to subtraction. So I have log base 3 of the numerator, 12 to the 3rd power, minus log base 3 of the denominator, 5 to the 3rd power. And now we're going to take those exponents and make them coefficients. 3 log base 3 of 12 minus 3 log base 3 of 5. This answer is perfect. If you wanted, because they both have that same coefficient, you could pull out the 3 and have it outside parentheses of 3 times the quantity log base 3 of 12 minus log base 3 of 5. That is another way that you could write that answer. Not necessary, but can be done. Still perfectly acceptable. Okay, example 5, log base 2 of x cubed divided by y squared. So again, our division quotient property is going to change into subtraction. So I'm going to take log base 2 of the numerator, x cubed, and subtract log base 2 of the denominator, y squared. Again, we do have that power property. Bring each of those powers to the front. So we'll have 3 multiplied by log base 2 of x minus 2 multiplied by log base 2 of y. And that's as simplified as that one can get when we expand. All right, number 6. We actually have looked at one that does have a square root. We're going to write that a little bit differently. Remember, if I have a square root of a term, so the square root of x can be written in rational exponential form as x to the power of 1/2. So we are going to take the argument that's inside parentheses that has the radical with it and change it to an exponent so we can use our power property. So we have log base 8 of w multiplied by the square root of u multiplied by v. Okay, so I'm going to start with log base 8. I'm going to keep what I have here of w, and then I'm going to change the u multiplied by v. I'm going to put it in parentheses and raise both of those to the power of 1/2. And all of that's one big argument. Okay, now I'm going to distribute that 1/2 power to each of those terms, the u and the v. So this becomes log base 8 of w multiplied by u to the 1/2 multiplied by v to the 1/2. Again, the square root turned into the power of 1/2. I then had to distribute that 1/2 to each of the terms using just regular exponential properties. And then in my next step, right here, I actually distributed, and now we're going to separate each of these 3 terms in the argument with addition because they're being multiplied. So log base 8 of w plus log base 8 of u to the 1/2 power plus log base 8 of v to the 1/2 power. And last but not least, we're going to take those powers that we have and put them as coefficients in the front of the terms. So we'll have log base 8 of w plus 1/2 multiplied by log base 8 of u plus 1/2 multiplied by log base 8 of v. That answer is golden. Again, if you wanted, you could put these back two terms in their own set of parentheses with the 1/2 in the front, but not necessary. This is perfectly fine as is. All right, now we are into condensing. 12 multiplied by log base 2 of x plus 6 multiplied by log base 2 of y. Our first check is to make sure that they have the same base before we do anything. There are coefficients in the front of each of the terms. So 12 log base 2 of x turns into log base 2 of x to the 12th power, plus 6 log base 2 of y turns into log base 2 of y to the 6th power. To put them in one log together, they both need to be log base 2. Because the logs are being added with the same base, I can then multiply those arguments together and put them in one set of parentheses. This answer is perfect. You could actually go a step farther if you recognize that x squared y, that quantity raised to the 6th power, would give you x to the 12th and y to the 6th. Again, not necessarily necessary. You don't have to do it. That's kind of like an extra if you get that guy. Yay, you. Okay. All right, example 8. Log base 8 of a plus log base 8 of b plus 5 log base 8 of c. All of them have log base 8. They're all being multiplied together, or excuse me, we will condense with multiplication because they're being added. But I do want to take care of that coefficient on the last term first. So I'm going to take an extra step just to make sure that I write that last term, 5 log base 8 of c, as log base 8 of c to the 5th power. Now, I know I have all the same bases, so I can condense them, log base 8 of a times b, or multiplied by b, multiplied by c to the 5th. And again, that is our product property. They're being added. I condense with multiplication. Example 9, 8, log base 9 of 12 plus 4 log base 9 of 11. Same base, check, check. Coefficients become powers, should be your first step. Log base 9 of 12 to the 8th plus log base 9 of 11 to the 4th power. Same base being added, change them to multiplication. This is our product property. So I'll write it as one log base 9 of 12 to the 8th multiplied by 11 to the 4th. I am 100% perfectly fine with this answer. I really don't want you to expand 12 to the 8th and multiply by 11 to the 4th power. Just leave it. This proves you know how the properties work. All right, each of these in example 10 are all divided by 2. Okay, so that really means it's 1 over 2, 1 over 2, and 1 over 2. So you could pull out 1/2 multiplied by each of these terms. So 1/2 times log base 3 of a plus 1/2 multiplied by log base 3 of b, and then plus 1/2 multiplied by log base 3 of c. Okay, that's the first thing I can do. That does show me that they all have that same coefficient, so we could shortcut it and write it as 1/2 multiplied by each of those logs separately. Log base 3 of a plus log base 3 of b plus log base 3 of c. And we can do that because they each have that same coefficient. So that's one way to go about it. In this case, we're checking to see if they have the same base, which they do. The terms are all being added. So I'm going to condense them with multiplication, power property. So 1/2 of log base 3 of a multiplied by b multiplied by c. And then to completely condense, we could actually take the 1/2, that coefficient, and make it a power for each of the terms, or of the entire argument is how we have it written currently. Log base 3 of a, b, c, all to the power of 1/2. That is one way to do that example. The other thing you could have done, I'll just show you very quickly off to the side, and we'll put this in another color, is you could have gone through and applied the power to each term. So log base 3 of a to the 1/2 plus log base 3 of b to the 1/2 plus log base 3 of c to the 1/2. Then recognize they all have the same base being added, so we can condense them into one log base 3 of a to the 1/2, b to the 1/2, c to the 1/2. And then from there, recognize they all have that same power, so you could then put that all outside of the parentheses. And last but not least, if you want to go as far as you possibly can, in either way, we still have log base 3 of ABC to the power of 1/2. Remember, the power of 1/2 actually means to take a square root. So we could also write this as log base 3 of the square root of A multiplied by B multiplied by C. That is the best answer of all of them written down. So white and green answers are the same, perfectly fine. If you take it to the next level and change your rational exponent into a square root, in this case, that is beautiful. Okay, a few more examples. 11, 12 multiplied by log base 6 of 2 minus 6 multiplied by log base 6 of 5. Power property, take care of that guy. So the first term becomes log base 6 of 2 to the 12th minus the second term becomes log base 6 of 5 to the 6th power. Same base, therefore I can condense log base 6 of, in this case I've got subtraction. Subtraction turns into division. The first log argument comes as the numerator, the second log's argument becomes the denominator. So it's log base 6 of 2 to the 12th divided by 5 to the 6th. That answer is good. If you recognize that you can factor out a power of 6, you would have 2 to the 2nd over 5, all of that raised to the 6th power. That answer is good as well. I like either of them. Doesn't matter to me. Be real careful when you're reading our next example. This is not 161n. This is 16 times the natural log of a minus 4 multiplied by the natural log of b. So now that we see it better and we're not mixing up the ones and the l's, then we're going to go ahead and take those coefficients, the 16, and make it a power for that first log, and the 4 and make it a power for the second log. So we have the natural log of a to the 16th minus the natural log of b to the 4th. Natural log is base e, log base e, so those are good. Subtraction gets condensed with division. So I can condense it to be natural log of a to the 16th power divided by b to the 4th. Absolutely love it. If you want to take those powers out another step, I could raise them both to the 4th power. B to the 4th gives me b to the 4th, and a to the 4th raised to the 4th power would give me a to the 16th. So that's another way you can write that solution. Okay, another bit of practice with change of base formula. Log base 5 of 6.3. Remember, in these examples, we need to put everything back into the natural log base e or the common log, log base 10. So we take log of the argument divided by log of the base. Type that into your calculator and let it do all the work for you. So log base 10, we don't write the 10, of 6.3 divided by log base 10 of 5 gives us 1.1436, and it says round to the hundredths place, so we'd say approximately 1.14 is its value. Example 14, log of 45. Look guys, look, check this out. Doesn't have a base written. If it doesn't have a base written, that is log base 10. So you really can straight up just type in log of 45 into your calculator. In this case, you got to be careful that you don't, mess up stuff, but that's approximately 1.65 rounded to the hundredths place. If you don't catch that, then you would do log of 45 divided by log of 10, which would still give you 1.6532, blah, blah, blah. So it estimates to about 1.65. Two more of these, and I think we're close to being done. I might toss a few extra things in here just in case. Log base 5 of 2.4 would be log of the argument, 2.4, divided by log of the base, log of 5, which simplifies to give us 0.54395. So if I'm only rounding to the hundreds place, I'm looking at the 3 and rounding it as needed. So it's approximately 0.54. And last but not least, log base 6 of 2.9 would be log of 2.9 divided by log of 6. Trying to type that in there real quick. Divided by log of 6. There we go. And this one is 0.5942. Again, rounding to that hundreds place, approximately 0.59. You got it. We do have a quiz pretty soon. Make sure that you're practicing stuff on worksheet C that's in your packet. Don't forget there is a little bit of evaluating and converting back and forth between the two. So if I have log base 3 of 9 equals 2 in exponential form, that means the base raised to the power equals the answer or the argument, and 3 squared does equal 9. Vice versa. If I have 5 to the x equals 25, if I want to put that in log form, it's log base 5 of 25 equals x. So you'll notice my base, my exponent, and then my answer or the argument. Here's my base, exponent, and then the answer or the argument. The other thing that we did on the first day was actually evaluating. So if you have an example of log base 2 of 1/32, and it says evaluate, that means that we are going to set this equal to x or y or whatever variable you like, rewrite it in exponential form. 2 to the power of x equals 1/32. Now I know that when I look at my powers of 2, 2 to the first, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16, and 2 to the fifth is 32. So I can rewrite this as 2 to the x equals 1/2 to the 5th power. I need this to be, let me write that a little bit cleaner, excuse me. Do not like how that looks as an example. So it would be 1/2 to the 5th power. You could actually write it as 1/2 to the 5th power because 1 to the 5th gives you that. Sorry, I accidentally lost what we were doing. Current slide, here we go. So back to this one, I could write that as 1/2 to the 5th power. Oh, it is jumping around on me. Okay, so sorry gang, this is going crazy. Here we go. That could be 2 to the x equals 1/2 to the 5th power. Because the 1/2 is a fraction, I need it to be an integer. So that would be 2 to the x equals 2/1 to the power of -1 multiplied by the 5, or 2 to the -5th. So when we're evaluating, log base 2 of 1/32 actually equals -5, that exponent that we have, because I got my bases to be the same. So make sure you practice a few of those as well. Sorry for all the jumpiness on that last problem. Hope you guys have a great day, and let us know if you need any help with anything.